Hello, a very warm welcome from my side to the today presentation of hydrophobing agents. My name is Markus Vogel and I work at Evonik in the Department of Architectural Coatings. I started at Evonik in 2007 and my technical background is paint engineer. When talking about facade coatings, we are talking about two aspects. First of all, we want to have a beautiful surface. Means we want to have a colorful facade. On the other hand, we are talking about the protection of facades. And this is the focus of the presentation today. The protection against, for example, water. What are the common challenges in hydrophobization of coatings, especially facade coatings? First of all, as mentioned, the protection against excess of water to the building. So, means we want to have a very low capillary water absorption of the coating or the wall itself. Optionally, we want to have a beading effect, a water beading effect, the so-called lotus effect, that the water droplet runs down the wall. Last but not least, we want to have long-lasting, beautiful colors on the surface. Means we want to have a very low dirt pickup so that we have over years a very clean facade. The protection of the wall is usually very easy. You can close the wall by a waterproof paint, so low PVC paint. The problem is that you have moisture in the wall, which leads to a pressure to the coating, which we see here. Then at the end it leads to blistering. Afterwards the pressure becomes higher and then it leads to cracking, or in the worst case to the decomposition of the coating. So there are different formulation concepts for facade coatings. First of all, you can formulate with a low PVC paint. Then you have a good protection against rain, so a waterproofed coating. The problem is that the coating is not breathable and the water vapor cannot penetrate through the coating. So, as in the last picture you saw, a pressure is built up and it can lead to cracking. The other concept is to formulate a high PVC coating. Here we are talking about PVCs above the critical PVC. Means you have an open port coating, so no protection against rain, means a high capillary water uptake. On the other hand, you have a high water vapor permeability, so a breathable coating. Using hydrophobing agents now, you can combine both properties. You have high PVC coating with high water vapor permeability, but also a low capillary water uptake. And this is what we want to have at the end for a good protection of the facade. What is the effect of hydrophobing agents in high PVC coatings, so open port facade coatings? When we have an open port coating, the water can penetrate through the coating by capillary forces, which we see on the left side. Using hydrophobing agents, we cover just the walls of the pores, and so we reduce the water uptake without influencing the SD value. So water vapor permeability is given. So we have combined two properties: reduction of the water uptake with high water vapor permeability. To characterize facade coatings, we determine different values. First of all, the water uptake, the so-called W24 value. In this case, we take a brick, paint the brick, and after drying, we put it to water. Before and afterwards, we weight the brick, and the difference gives us a value for the water absorption. On the other hand, we determine the water vapor permeability, means how much water vapor can pass through the coating in a defined time at defined conditions, 23 degrees, 50% humidity. In both cases, we want to achieve a low water uptake, so the best class in the water uptake, combined with a very high SD value, high water vapor permeability. In addition to these standard test methods, we also evaluate the dirt pickup and the contact angle of the surface. For the dirt pickup, we use a modified dishwasher to have an accelerated dirt pickup test. In this case, we spray a dirt dilution on the dried panels and determine the L value before and after the tests. The difference in the L value gives us an idea about the dirt pickup. The lower the delta, the better the dirt pickup. Last but not least, we evaluate the contact angle. Means we put a droplet of water to the surface and measure the contact angle between the water droplet and the coating. The higher the contact angle, the more hydrophobic is the surface and the more it goes in the direction of a water beading effect. Here you see the chemistries we use for our hydrophobing agents. First, silanes. Monomeric molecules contain only one Si. These low molecular weight silanes are mostly used for impregnations, our Phobe 6000 series. Then we have linear structured polysiloxanes, our Phobe 1400 and 1500 series, mostly used to adjust the contact angle on the surface, so a polysiloxane to achieve a beading effect on the surface. And last but not least, silicone resins, in most cases emulsions. These are highly branched molecules of higher molecular weight. And these silicone resins are used in silicone resin paints for sure, but can also reduce the water uptake in other formulations. Here we see the highlights of our hydrophobing agents of our product portfolio. The deep purple cards are emulsions, just for water-based formulations, where the blue card, the Phobe 1500N, can also be used in solvent-based coatings. Now we want to describe these products more in detail in the following slides. The first product I want to highlight is the TEGO Phobe 1659. This is a silicone resin emulsion, 50% active matter with the application fields of plasters, silicone resin paints, polysiloxane paints, so always to reduce the water uptake. We say it is for the internal hydrophobization of coatings. It provides low water absorption, very good early water resistance with a moderate beading effect on the surface, and finally it provides a very low dirt pickup compared to other silicone resins. In this graph you see the values of the W24 determination, and you see even at a dosage of 4.8% in this very high PVC coatings we achieve easily the best class in the water uptake. With products of the competition, usually you need much more of the product to achieve the best class in the water uptake. This means highest efficiency at lowest possible dosage. For sure, you can also use it in lower PVC paints, and then you can reduce the dosage of the Phobe 1659 to achieve also the best class in the water uptake. At the beginning of this presentation we mentioned already that one target is a very low dirt pickup. Here we see an example from our accelerated dirt pickup tests. So we took plasters, put them in the dirt pickup machine and evaluated the L value. And here you see clearly that Phobe 1659 has a very low to no influence on the dirt pickup, whereas other silicone resins in the market influence the dirt pickup in a very negative way. So in this case, we stay really on the level of the blank sample. So Phobe 1659, the silicone resin. What you expect from a good silicone resin for sure, low water uptake, low dirt pickup. But we have many other benefits by using Phobe 1659, especially in plasters, which we now show you in a short video. Here we have two formulations, one with Phobe 1659 and the other one with a market standard. Here my colleague, a professional painter, applied this plaster to a substrate, and it is really difficult to show in a video, but you have to trust me. He told me it is really easy to apply when you use 1659 in a plaster formulation. And at the end you see here that you get a very homogeneous surface without any pinholes. Using the market standard, maybe you see it a little bit in the video that it is much more complicated to apply it. And especially here you see it is not so easy to homogenize it. And at the end you have some mistakes on the surface. This is due to the high pigment affinity of the Phobe 1659, which is much better than the market standard, which leads then to a perfect surface without any failures, without any mistakes, and with a perfect water protection of the facade. The next product is the TEGO Phobe 1409. This is a linear structured polysiloxane, first of all to achieve a water beading effect. It gives also a very good early water resistance, the water beading effect, so the water droplet runs down the wall, and can even be used at very high pH values, for example in silicate paints. This is one of the applications. For sure you can also use it in polysiloxane paints or plasters, more for the exterior or external hydrophobization, so to hydrophobize the surface of the coating to have this lotus effect on the surface. As a hydrophobing agent, the TEGO Phobe 1409 will also reduce the water uptake as a silicone resin, also at very low dosages. In this case, roughly 4% of the hydrophobing agent is used, and you can see that easily the best class in the water uptake is achieved in comparison to other grades in the market. The most important benefit of using TEGO Phobe 1409 in a siloxane paint or in a silicate paint is a high contact angle on the surface. Here you see the example in a silicate paint. Silicate paint means very high pH values, pH value of 12, 13, so very aggressive medium. So even in this medium, Phobe 1409 will provide high contact angles over time and also after the storage in the paint, where most of the products in the market failed after the storage. So here you can see that it is easy to achieve contact angles of about 140 degrees by using Phobe 1409 with a dosage of roughly 4% in the formulation. For sure, if you use formulations with a lower PVC pigment volume concentration, so higher binder demand, you can achieve such contact angles with a lower dosage. In this short video now we see the effect of TEGO Phobe 1409. We have two paints applied on a mineral substrate, on the left without any hydrophobing agents and on the right with TEGO Phobe 1409. And now we let it rain with TEGO Phobe. And you see on the left side the water is soaked up by the substrate, by the coating, and on the right side you have the real beading effect. So water is running down the coating, and for sure at least it is also leads to a faster drying of the facade, yeah, which then also can give advantages in the growth of algae, which can be reduced by a faster drying wall. But most important here is, as you see, the water droplets, the water beading effect, which is caused by the usage of TEGO Phobe 1409. To achieve really the highest contact angle of a surface, we have the TEGO Phobe 1500N. This is again a linear structured polysiloxane, but in this case it is solvent based, means the active matter is dissolved in a solvent, 50% active matter. You can use it in solvent-based formulations for sure, but as well as in waterborne formulations. Here you can really achieve high contact angles, which we see in the next slide. In this graph you see the contact angles in a polysiloxane paint with Phobe 1500N and Phobe 1401, an older product, in comparison to the control panel. And you see that with 1500N you can achieve really up to 150 degrees of contact angle, which means a really strong water beading effect. The last product I want to highlight in this presentation is the TEGO Phobe 6510, one of our Phobe 6000 series. You remember, it is silane based, means first of all you use it for impregnations and primers of mineral substrates. The big advantage of the silanes is that they can really react with the substrate. So they are really anchored, chemically bonded in the substrate. Usually you use them for impregnations on concrete or natural stones. The big advantage of these products by using it in an impregnation is that the natural appearance is not affected by using these TEGO Phobes. The 6510 is a water-based product, a silane which is emulsified in water, and then it is used by dilution for an impregnation or in combination with a binder as a primer for mineral substrates. It gives also a water repellent effect, so beading effect on the concrete for example, as well as it reduces the water uptake very efficiently. Here you see one benefit of using the Phobe 6000 series in impregnations and primers on mineral substrates. By reduction of the water uptake, the transportation of the salts from the mineral substrates to the top of the surface is avoided or reduced, and so you cannot see any efflorescence on the surface by using Phobe 6510, for example, in an impregnation. For sure, in addition, it gives a water beading effect, and by the silification, it gives also a long-term effect because it's chemically bonded in the substrate. In this graph, you see the influence of the dosage of the Phobe 6000 series, in this case Phobe 6510, in impregnations. Due to the requirements of the customer, he can dilute 6510 down to 5% active matter, and he will reduce the water uptake and combine it with the water beading effect. For sure, the higher the dosage, the higher the concentrations of the Phobe 6510, the lower is the water uptake and the higher is the water beading effect on the surface. As a summary of this presentation about hydrophobing agents, we can say we have the silicone resins TEGO Phobe 1659, which you can use in silicone resin paints and silicone resin plasters, mostly to reduce the water uptake of these formulations. The second class of products are the linear structured polysiloxanes, the Phobe 1409 and the Phobe 1500N, also to reduce the water uptake, but here the focus is clear on the contact angle, so you can achieve a real water beading effect by using these TEGO Phobes. The last class are the silanes, the reactive materials, which are mostly used in impregnations and primers for mineral substrates. Here we are talking about our Phobe 6000 series with a focus on the Phobe 6510 for waterborne formulations. At the end of the presentation, I don't want to miss the chance to give you the information about our website, where you can find also guiding formulations for all the mentioned applications, like silicone resin paints, polysiloxane paints, impregnations and primers. For sure, if there are any open questions or if you need more information, feel free to contact us in the Department of Architectural Coatings, and we will support you.